So it says which value of A you'll have to forgive. I have it bold ordered, so it'll just be a few days of this idiocy. I don't know. Okay, so it says which value of A is the solution to the sine of A. So we're trying to find this value that makes this a true statement, right? So we're trying to find A. So a couple different ways of doing it. You could use your circle. Remember that in a unit circle, our cosine is our x values, right? And sine is our y values. We have x, y points. So we have a bunch of x, y points on here. So I'm going to locate the place where sine is square root of 3 over 2, which right there it happens, right? But it also doesn't happen right here. Yeah? Right? Doesn't it? Okay, so all step either after. So the answer is, it happened at sine of pi thirds, right? Everybody? Does everybody see how it happened at pi thirds? Does that make sense? Isn't that where sine was square root of 3 over 2? So you say pi thirds. So A is pi thirds, because sine of pi thirds is that. Or you could have said 2 pi thirds, because sine of 2 pi thirds is the square root of 3 over 2. Now also, I guess, for this time I would accept, why not? 60 degrees would have worked. Isn't that the same thing as pi thirds? That's just in degrees. And then 120 degrees would work, but I would probably prefer it in this, but either will get the right answer. Okay. Now you could have also, if you remember back to secondary 2, you could have also taken your calculator and done, okay, so I need to, we're trying to solve for A algebraically, right, everybody? So if you need it's entrapped in sine. So to get this alone, couldn't you take this inverse sine? You should have learned this in secondary 2. So then inverse sine and sine cancel out. Isn't A alone? So we have A is equal to sine inverse of square root of 3 over 2. You could have typed that in your calculator as long as it's in degree mode. So you could have typed in second sine inverse of the square root of 3 divided by 2, and you get 60 degrees. Isn't that what we just said?
Yep.
So there's many different ways. We're really cool now that we're in secondary 3. Yeah. Good question. One would have been okay. Now I might say there are two answers. Where does this happen twice? And that's why we would prefer our unit circle. Because if we did it algebraically, we might not see both. Does that make sense? We wouldn't see both. Okay, awesome. Okay, let's move on to what we're doing today. So we're going to be now graphing the cosine function. The cool thing is it's very much similar to the sine function. So it's not going to be really super hard today, but it is a little bit different, couple of different little things. So let's just get started. So remember, when we were graphing the sine function, we were going around, technically what we were doing was going around the unit circle, and it created a sinusoidal wave. That's exactly what we're doing with cosine. We're going around the unit circle. Remember, cosine is x values, so we have cosine of theta, sine of theta, sine of y values. So today we're focusing on the x values around the unit circle. So let's graph how cosine is going to end up. So first of all, we know our unit circle has a radius of 1. So that's why I went up 1, down 1. Does everybody understand that? It's an amplitude of 1. Okay? Because here's the midline, right? So we'll be traveling up 1 and then down, from here, down 1. You see how the total distance would be 2? Does everybody see what I'm saying? Okay, so going around, let's graph the cosine function. So we start at 1, right, with this one? So with cosine, we start up at 1. So we start up at 1. Now we're going up, we're going down, down, down till we hit 0. So we started at 1, we're going down, down, down till we hit 0. Does everybody see how I'm right there? Now we're traveling down again, down, down, down to -1. So we're going down, down, down to -1. Now we're going back up to 0. So back up to 0. And then we're going back up to 1. So back up to 1. There's 1. So that's our cosine function. That's how you draw that. So it does look a little bit different than the sine function, right? Kind of easy way to kind of help me remember the difference. Doesn't that kind of look like, this is exaggerating very much so. Doesn't that kind of look like a sideways C? Cosine? And then sine looks like, sine whiz, we went up, down, up, so it's kind of like more of an S. Okay, well if you don't see it then you're blind as a bat, so. Okay, that was a joke. Don't get offended and walk out. Okay. I'm just saying, but you guys see how algebraically this works, right? That's all you need to be able to do. Okay. So it kind of, sorry, it droops a little bit better. It kind of looks more like this. It's hard to just freehand it. So it kind of just like a, whoop. Does that make sense? So we could go around the unit circle again, guys, and the same thing would happen. Now, doesn't that look very much like sine, guys? Do you see what you could do? We could go around the unit circle again and so cosine and sine do look very similar, but yet they are a little bit different. So now let's fill in our x line here. So right here was 0, right? And then right here's 0, and we were at 1. And then we went down to 0 at pi halves. So right here we were at pi halves, right? Everybody? And then we went down to -1, and that was at pi. And then we went back up to 0, and that was at 3 pi halves. And then we went from 0 to 1, and that was at 2 pi. So 0 to 1, 0 to 1, and that was at 2 pi. So does everybody see how we split it apart? Okay, questions on that? Okay, so cosine looks very much same as a sine function. Y is equal to A times the cosine of B theta, where A, the absolute value of A is the amplitude, and B is the number of cycles from 0 to 2 pi. The important part is the number of cycles from 0 to 2 pi. A lot of people like to say, oh, that's the period, but that's not. That's the number of cycles you're going to see between 0 to 2 pi. And cosine cycles look like this, right? I just drew it for you. Okay. Now our period is still the physical length of one cycle, and it's the same formula as for sine. It's 2 pi divided by b, and b is the number of cycles. So you'll say 2 pi divided by b, and that's the physical length of one cycle. So this is the period. Okay, same as sine, just a little different. Okay, questions on that? Okay, so it says, find the period and the amplitude of the cosine function. Determine the values of theta, so determine the values of theta for which theta is between 0 and 2 pi, that the maximum and minimum, and zeros occur. So let's just focus on this in pieces. It says, find the period and the amplitude. So period means what? The length of one cycle, right? Everybody? Okay, so we're looking here. Now notice this cosine function, I always like to start at 0. It starts down at the bottom, which is fine. It has a negative in front. Now cosine, it goes all the way up, back down, and that's one cycle for cosine. Right? Then our cosines look like the C thing, like I just talked about. Okay, so we have the length of one cycle, that's the period. What did it end at? What's the length of one cycle? Look. What is it? Where did it end? At what value, guys? Pi. So the length of one cycle is pi in length. Does everybody understand how that's the period? Okay, so then amplitude, halfway up from the midline. So you can do this a couple different ways. You can say, what's the total distance divided by 2? But let's look, this is working in 1, 2, 3, right? Isn't this the midline? So our amplitude is 3, right? So our amplitude is 3. Or you could say our total distance was 6 divided by 2 is 3, which is our amplitude. So we've answered those questions. Any questions on either of those before we get to the next part? So on this next one it says, find the values of theta between 0 to 2 pi. So we're only focusing from 0 to 2 pi. And we want to find the maximum and minimum values and zeros that occur. So I'm going to go through and find the maximum values. So I'm going to write maximum. Now we're talking on the x-axis. So a max happens right here. Isn't this as high up as it goes, between 0 to 2 pi? So it happens in those two spots. But we need to figure out where that lands on the x-axis here. So right here and right here. Well look, isn't from here to here pi? So isn't this going to be halfway through there? So pi halves? So this is pi halves and this is 2 pi halves, right? So this is 3 pi halves. So we know that the maximum values happen at pi halves and 3 pi halves. Questions on where my maximum values are happening. Okay, let's do minimum values now. So our minimum values, it happens right here, and we're talking from 0 to 2 pi. There's a minimum, there's a min, and there's a min. All right, so at what x value did this min happen? 0, good. What happened? Yep, right there, right? Pi. And then 2 pi, good. And then it says, what values do the zeros occur? Zeros are x-intercepts, guys. That's the same with all kind of functions. So if I say find the zeros and I give you a quadratic, we're finding the x-intercepts, right? Okay, so zeros, or where it's crossing the x-axis. So I'm going to change colors again. I guess I'll go with purple. So it's crossing the x-axis right here. Sorry, it's hard to see from me. Right here. Crossing the x-axis right there, right? Right there and right there. So, oh, I thought it was going to cross exactly on those points. That one's kind of hard to tell. Okay, kind of hard to tell, but let's look at it. Okay, so isn't that look halfway between those two? Doesn't it look halfway between those two? So that's divide pi halves in half and you get pi. So that's pi fourths. So there's 1 pi fourths, 2 pi fourths. This is 3 pi fourths. This is 4 pi fourths. This will be 5 pi fourths. And this is 6 pi fourths, right?
7 pi fourths.
7 pi fourths. And then once again, the ends of 8 pi fourths, that is 2 pi. So our zeros happen at pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. So just not super hard, but it took us a minute to think about it. That's not a bad thing, okay? All right, any questions on those, or you just want to start practicing asking questions? That's how we learn. Okay, let's practice. So do problems 1 through 3. So now we're just going to practice graphing. It says sketch a graph of each function from 0 to 2 pi. So notice in the directions it says, it doesn't say just sketch one cycle. It all depends on what we're given. If it said to sketch one cycle, we'd only sketch one cycle, right, everybody? But this one says sketch the graph of the function from 0 to 2 pi. So we're going to draw in as many cycles as we need to get to 2 pi. So what I do is I list out, first of all, my amplitude. So what's my amplitude in this equation? 1, right? It goes without being said, there's a 1 there. So my amplitude is 1. So I know I'm going up 1 and down to -1. And then I like to draw in my asymptote so I don't go above that or below that. Now also, remember that this is the b value, which b is the number of cycles from 0 to 2 pi. So how many cycles do we have from 0 to 2 pi? A half of a cycle. Okay, and then our period is the physical length of that of a full 1 cycle. So you take 2p, 2 pi divided by b. So 2 pi divided by 1/2, which is equal to 4 pi. If you don't believe me, take your calculator, do 2 divided by 1/2, hit enter, you get 4 pi. Okay? But now, keep in mind, we're only going from 0 to 2 pi, so how many cycles are we drawing in?
1/2.
A half a cycle. So remember, cosine is something like this, right, everybody?
Yep.
We're only going to draw in a half a cycle. So now I'm going to go ahead and do that. So I'm drawing in a half a cycle. So it starts up here and down. Stop, okay? So I drew in half a cycle, and that's from 0 to 2 pi, right?
Yep.
So we ended at 2 pi. So it's a way stretched out cosine, right, everybody? And then, so if I wanted to label it a little bit prettier, halfway between would be pi, right? And then halfway between that would be pi halves. So then I like to count 1 pi halves, 2 pi halves. So right here would be 3 pi halves. And that's good enough for me. So to get it to a full cycle, we'd have to go up another, and we would end at 4 pi, right? The length of 1 full cycle is 4 pi. So it says draw in from 0 to 2 pi. Doesn't say draw in 1 cycle, or we would have kept going, right? Okay.
How do you know where you start at?
Cosine starts right here if it's not shifted, and we will have shifted later. It starts up here. If it's positive cosine, it shoots down and up. This is what a cosine function looks like. You start up, down, up. There, that's a little bit better. Like you start up here, Miss.
Yeah.
Okay. All right, moving on to the next example here. So it says sketch the graph of each function from 0 to 2 pi. So we're going to draw in, it just depends. So once again, this one's a little bit trickier. What's my amplitude? Absolute value of -2, right? Which is 2. So our amplitude is 2. So we're going up, 1, 2. and drawing in an asymptote. We're going down 1, 2, drawing in an asymptote.
So you start from top.
Yeah, good. So with this one, yeah, we'll just, the negative flips it over the x-axis, right? So we would start down here. But let's first figure out the number of cycles we're going to be drawing in.
Pi.
So our period, our b value, the number of cycles from 0 to 2 pi is pi over 3, but that's not the length of a cycle, right? That's the number of cycles. So how many cycles is that? Well, isn't pi thirds just a number? It's just a decimal? Okay, let's figure out about how many cycles we're drawing in here. So take your calculator. What's pi divided by 3? 1.04, right? So we're drawing in 1.04 cycles. So a little bit more than one cycle. Does everybody get that? Okay, so let's do that. Now, because of the negative, we have to start at the bottom. Now remember, so our cosine function looks like this, one cycle, right? The halfway C. Do you guys see what I'm saying now, kind of to help you remember? Okay, so we're starting at the bottom. We go all the way to the top, then we're doing 1.4, so a little bit more than, so you see how I'm kind of curving up? 1.04. Okay, so that ends at 2 pi, right? Because isn't this between 0 to 2 pi? So we ended at 2 pi. All right, so then cutting that in half, it's kind of hard to do because we're doing, that's 1.04, so it's a little bit closer over here than halfway mark, right? So like this is pi, right? So then, I mean, I would cut that a little bit in half right here. This will be about pi halves. But do you see how I'm kind of in front of it a little bit? Okay, that's about as good as I really care. 1 pi halves, 2 pi halves, so this will be about 3 pi halves, right? Does everybody see how I did that? Okay. So, and then if we want to know the length of one full cycle, just saying, you know, you take period is equal to 2 pi divided by the b, so pi divided by 3, flip the second and multiply. So our period, the length of 2 cycles would have been 2/3. The length of one cycle would have been 2/3. So, yeah, keep that in mind. Oh, you know what though?
What?
So because we were dealing with 1.04, I think what they would want us to do is actually write out the actual x length here. So what is 2 pi? 2 pi is 6.3, right? So maybe instead of 2 pi, we should write this instead. In fact, we should. So that's 6.3, and then 3 pi halves is 4.7. So this is about 4.7, and then that's about 3.14, and then pi divided by 2.
So if it's like not right on.
No, the difference was our period, the number of cycles was this, right?
Yeah.
And that's hard to like, what is pi thirds? It's a number. Does that make sense? So the difference was usually we just get a number, and so we would label it with the pi's. But where we didn't get a number, we wrote it out like this. So we'll write out our x-axis like that. Okay. So then pi halves is 1.6. Okay, does everybody see what I'm saying here? Okay, so now I want you to do, but you know, it doesn't hurt to do both, because then you just know that they're equal. It doesn't matter. They're the equal things. I was just thinking of what they'd want, and I think they'd want this. Okay, so do 4 through 7, go. Okay, so it says write a cosine function for each description. So you've got to really not make any mistakes with this, because a lot of students will mess it up because they won't think about what the equation of cosine looks like. So I'm just going to write that down. Remember, the equation of cosine is y is equal to a times cosine of b theta, where a is the amplitude and b is the number of cycles from 0 to 2 pi. Okay, so that's not the period, is it?
Nope.
So don't make that error. So we have y is equal to, the amplitude's 3, so that's easy. 3 cosine. Now the b theta. Well, we have no idea what b is, but we do know our period's 2 pi. So remember, there's a formula for period. Period is equal to 2 pi over b, right?
Yep.
Well, in this one, aren't we given the period?
Yep.
So let's put it in where it goes. So it'll be 2 pi, because we were given the period, is equal to 2 pi over b. Now let's solve for b algebraically.
Times by b.
Good. Multiply by b, it divides out over here. So we have b 2 pi is equal to 2 pi. Now to get b alone, won't we divide by 2 pi? Divide by 2 pi, which is 1. So the b is 1. So cosine of 1 theta. I'm going to just write theta because that's the prettier answer. Pretty easy though, right? Just some algebra involved.
So when it say 2 pi was on the amplitude, would you do the same thing?
2 pi, right? If 2 pi was the amplitude, you just write 2 pi because that's physically a number, right? But we'll just write 2 pi. Good question. Because if we needed to graph that, right, we go up. 2 pi is 6.3 units. We go up that high. Does that make sense? Right? Because that is just a number technically. Okay. So do 8 through 12. In this problem, you are given a period, right? You guys are plugging that right into the equation. Is b period?
No.
No, that's a number of cycles from 0 to 2 pi. So you can't just plug that in. Wrong. You have to know, okay, I know that the equation for period is period equal to 2 pi over b. Now put in what you know. You're given the period, whatever it is. If it was 10, you put 10 right there. Right? So it's 2 pi is equal to, because I put that in right here. So if it was 10, I'd say 10 is equal to 2 pi over b. Then we've got to solve for b algebraically. And once we know b, then we know that.
Yep.
Does that help everybody? Because like 90% of you got those ones wrong. So I'm going to maybe do another example.
Okay.
Okay. Okay, identify the period, range, and amplitude. Identify the period, range, and amplitude. I'm going to do some problems off your worksheet. You won't have as many to do if you'll follow me through this. So first of all, remember that cosine has the form y equals a times cosine of b theta. You've got to know what each thing stands for. That's the amplitude. And b is the number of cycles from 0 to 2 pi. Okay. Oh yeah, also everybody look back at problem number 10. Do you see how your cosine function started below?
Yep.
Don't you have to have a negative in front on your equation?
Yes.
A lot of you forgot the negative. Add it on there.
Use.
Okay. All right, number 25. So first of all, find the period. So, and amplitude. Amplitude's the easiest. So my amplitude is the absolute value of -1, which is
1.
my period. Remember that period's equation is equal to 2 pi over b. What's our b value?
1.
1. So what's our period? 2 pi. Does everybody see how I'm doing this? My b value was 1, right? So I just plugged it in. Okay. And then my range. Range, remember, anytime I say what's the range, you know you're looking at the y values of the function. How far up and down does my function grow? So if it has an amplitude of 1, isn't it going up 1, down 1? Okay. So it's bouncing between -1 and 1, right? Now range is y values, so you'll write it as an inequality. Our y is greater than or equal to -1, right? Isn't y greater than or equal to -1? But it's also less than or equal to +1. Below 1 and above -1. So this is my range, my y values. Does that make sense? It's bouncing between -1 and 1. Okay, awesome. One more, then I'll just let you finish up a few. Okay, number 26. What's the amplitude? 1, right? There's a 1 right here. My period, remember you need the, we're given b right here. So period is 2 pi divided by b, which is 2 pi divided by 2 pi, which is 1. So my period is 1. That's the length of a cycle. So we're talking not pi radians if we were to graph this, but just radians. But we're not graphing. And then my range. Well, once again, my amplitude is between 1 and -1. So my y values, that's what range is. So my y values are between -1, they're greater than -1, or equal to -1, but less than or equal to 1. So what's my domain on these? Isn't a sinusoidal wave continuing forever? Negative infinity to positive infinity. It didn't ask you the domain, but right, if I ask you the domain, easy, right? Can't we keep going around the unit circle forever? So it'd be sinusoidal waves continue. Good. All right. Any questions on how to do these ones? Okay. Awesome. Now these are what you have to finish up on the worksheet. So you are skipping 13 through 24. We're not doing those at all. We're not yet. You can cross them out. But you are doing 25 through 30. I just did a few of those with you. And you guys, the whole reason we learn this thing is to be able to do real world problems. Do number 32. I know you can do it. It's not super hard. Draw a picture if you need to. I graphed it on 32 and looked at it. It's no different. Just answer the question, guys. Draw a picture just like you would if it wasn't a story problem. Okay? If you have to do 32. The whole reason we learned all this is to be able to do stuff like 32. Now, one thing to note is if it says what is the length, or like something about revolution. Anytime you see the word revolution, it means from 0 to 2 pi. So that'd be like, so it's from 0 to 2 pi. The revolution is from 0 to 2 pi. Does everybody know what I'm saying? Yeah. Okay, so you'll have to remember that. If I ever say, so how many times does it go around in one revolution? You'll say, how many cycles is there between 0 to 2 pi? Because a revolution is from 0 to 2 pi. Okay, go.